Welcome to everyone. So in this lecture, we are going to discuss about foundation engineering. In the previous classes, we discussed in shallow foundations. In this lecture, we are going to discuss about pile foundation. Okay. So before going to lecture, generally, what is a pile foundation? Generally, pile foundation nothing but the deep foundation. These deep foundations are required when the soil at shallow depth is not capable of supporting structural loads, then deep foundation will be adapted. If a stratum having desired bearing capacity cannot be reached by open excavation, then the deep foundation will be the option. Okay? The main purpose of the pile foundation is to transmit a superstructure load. Generally, superstructure load means generally there are two types of the structures. One is the substructure, another one is the superstructure. Substructure means below the foundation, that is, in the below the foundation there will be a footings. These called as nothing but a substructure from the above plinth level. From above the plinth level, whatever we can see with the naked eyes, above the plinth level, like foundation and other structural elements like columns, slab, beams, staircase, and walls. These are all the elements are nothing but the superstructure. Generally, in a multi-story commercial and residential building, the superstructure load will be more. For example, for a construction of a Z plus 3 multi-story commercial building, if you see that G plus 3 means here there are 4 floors: ground floor, first floor, second floor, and then third floor. If you estimate that each floor is having have 3.8 meters or 3.6 meters of height, an average, if you take it for the 4 floors, there will be 14.4 meters height. If a single floor can give a dead load and live load, for the 4 floors with the height we can estimate the total load which is coming onto the foundation. Generally, if you see the load carrying capacity structure, at finally in a building will be having parapet wall at most element. The top element is the parapet wall. From the parapet wall, the load is nothing, the parapet wall load is nothing but dead load, because this is a dead load. The parapet wall dead load will be coming onto the slab. This slab will carry the load of the parapet wall and its own self weight of a slab. Again, this slab load and parapet wall, again it has been transferred to the beams. Beams are the horizontal structural elements which are being resisted to the transverse loads. These beams, again its own self weight and slab load and parapet wall load will carry to the columns. Again, these columns, their self weight and slabs and beams and parapet wall load, this again these loads are dead loads, are carried to the foundation. Again, this foundation transfer the load to the footing. Again, these footings, the total load will carry to the soil. Here the main thing is that you need to understand the soil will be the main strata which can bear all the superstructure and substructure load coming here. Here the main purpose of pile foundation is to transmit a superstructure load to deeper load bearing strata to withstand lateral, vertical, uplift load to minimize the settlement. Understanding here, to minimize the settlement, these superstructure load will carry to the deep bearing strata. Okay, a structure can be founded on piles if the soil immediately beneath its base does not have adequate bearing capacity to withstand the desired structure loads. Okay, if the results of site investigation show that the soil at shallow depth is unstable or if the estimated settlement is beyond acceptable limit, then also a pile foundation will be adapted. Okay, so let's start our lecture with pile foundation. First thing is that necessity of pile foundation. I told you that generally in shallow foundation at open excavation, generally for constructing any building, the first step is nothing but the site clearance. After site clearing, next step is nothing but the locating of footings. For footings purpose location of that, then we'll have the excavation, that is the digging. Then in the open excavation, at a normal shallow depth, if you get a hard strata, then it is nothing but the shallow foundation. If at a shallow depth, if we're not getting a hard strata, then we go for the pile foundation. See, I told you that in superstructure load, the total load will be carried by the beneath the soil. That means soil should have the more bearing capacity. Okay. For depending upon the construction type, we'll check the soil bearing capacity. Okay. Based on only the type of foundation will be selected. In most of the cases, at shallow depth, if you are not getting hard strata, means we'll go for pile foundation. Okay. The first case here it explains about the when the loads are heavy. Here heavy means when the loads are heavy means generally in a multi-story complexes, multi-story commercial complexes or multi-story residential buildings that is more than Z plus 10, or generally we say that G plus 3, more than G plus 3, we say that generally that the high-rise building generally. In this high-rise building, definitely the loads are heavy because if the floor number is increased, the load also superimposed, right? Due to the floor number increased, here the loads also increased. When the loads are heavy, in this particularly the loads are very heavy and soil is poor. Generally, if you see that at a low shallow depth, if you're getting the clay soil, generally in these conditions very soil is very poor. In these cases definitely we have to go for pile foundation to get the hard strata. Next, coming to the second point, transferring soil from soft medium to hard strata. Generally I told you soil at a shallow depth, the soil is having some medium bearing capacity which cannot bear the heavy loads, then these soil transfer from soft medium to the hard strata. So that is the meaning here. Then another condition is that what is the necessity of pile foundation means when the soil at a shallow depth is weak. I told you that generally gravelly soil will be having the hard strata. When you have the clay soil and sandy soil at shallow depth is very weak, okay, to bear the heavy loads. Another thing, if the structure is to be constructed in water, generally the bridges and the elements like columns will be constructed in water most of the that. In these particular cases, generally the load will be more. Okay, in these cases generally we have to go for pile foundation. Next, another one is the for machinery foundation. Also, there is a pile foundation is necessary. Foundation subjected to the uplift pressure. Here, uplift pressure generally in dams, uplift pressure is an upward vertical pressure that is created due to water pressure is created at the bottom of the dam in porous material. These uplift pressure will be created. Okay, generally in dams generally upward vertical pressure is created due to the penetration of water into the porous medium at the dam basement. These uplift pressure will be act. So foundations subjected to the uplift pressure like dams in pile foundations will be preferred. Another one, foundations or structures subjected to the lateral loads. Generally, lateral loads means the vertical loads which is acting from the superstructure. Okay, so for that also the pile foundation will be preferred here. Okay, so these are the main necessity of the pile foundation. I told you that the purpose of pile foundation is mainly to transmit a superstructure load to deeper load bearing strata to withstand lateral, vertical, uplift load and to minimize the settlement. This is the purpose of the pile foundation. Okay. Next, coming to the next slide, classification of piles. So generally there are different criteria will be followed. Uh, that is the classification of the piles. First, let us see that based on the displacement of soil, there are two types of the piles. One is the displacement piles, another one is the non-displacement piles. The first one is the displacement pile. Generally, piles which cause lateral displacement of soil when they are installed is called as displacement piles. Piles which cause piles which cause lateral displacement of soil when it is installed is called as displacement pile. Example, we can say that all driven piles are displacement piles. Okay, that means here there will be a lateral displacement where the lateral displacement will be there. That is called as displacement pile. Coming to the non-displacement piles which cause no lateral displacement of soil is nothing but the non-displacement piles. That means no lateral displacement of soil when the pile is installed. So non-displacement pile is nothing but no lateral displacement of soil when the pile is installed. Example, we can say board 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 piles. So understanding here, Based on displacement of soil, there are two types of the piles. One is the displacement piles, another one is the non-displacement piles. Displacement piles means piles which cause lateral displacement of soil when it is installed. Another one is the non-displacement piles. No displacement of no lateral displacement of soil when the pile is installed. That is nothing but the non-displacement piles. For example, is displacement pile is nothing but the all driven piles, and for non-displacement piles, example is the bored pile. Okay. So next, coming to that, under classification based on function of pile here. So coming to the based on function of pile, there are five types of piles here. One is the compaction piles, tension piles, anchor piles, batter piles. Another one is the fender piles and dolphin piles. It is fender piles and dolphin piles. See, let us see each and every one. First one is the compaction piles. These compaction piles used to compact loose. These compaction piles are used to compact loose granular soils. Loose granular soils. Generally, these compaction piles are used to compact loose granular soils in order to increase the bearing capacity of a soil. Okay. Generally, these compaction piles are not required to carry any load. The material required may be strong. In fact, sand may be used to form the pile. Okay. Pile tube driven to compact the soil is gradually taken out and sand is filled in its place and forming a required pile is called a sand pile here. Okay. This compaction piles do not carry any load, hence they can be of weaker material. So sand piles are used as compaction piles. Sand piles are used as compaction piles. I told you that generally compaction piles are used to compact loose granular soil to increase its bearing capacity. But the thing is that compaction pile do not carry load, so that sand piles can be used as a compaction pile. Okay. Next, coming to that second one, tension pile. So these piles are also called as a uplift piles. These piles also called as a uplift piles. Generally, these piles can be used to anchor down the structures which are subjected to uplift pressure due to hydrostatic force. I told you that generally uplift pressure, the vertical upward pressure which is created to the penetration of water in the porous medium at the structure. Okay. So these tension piles are also called as a uplift piles. Okay. These piles are used to anchor down the structure which are used to uplift pressure due to hydrostatic pressure. Generally, hydrostatic pressure is also a vertical pressure. Okay. Here in tension piles, the piles are under tension. Okay. Here piles are under tension. Next, coming to the third one, anchorage piles. Anchorage piles are used to provide anchorage against horizontal pull from sheet piling. Generally, simply we can say these anchorage piles provide anchorage between horizontal pull between horizontal pull from sheet piling. So this is the purpose of anchor piles. Okay, simply we can say that to provide anchorage against horizontal pull from sheet piling. Okay, these are anchorage piles to provide anchorage between horizontal pull from sheet piling. Okay. Next, fourth one is the batter piles. Batter piles are provided at inclination to lateral forces to resist lateral forces or inclined forces. Okay. So batter piles are provided at inclination to resist lateral forces or inclined forces. These batter piles are used. So especially in waterfront structures, these batter piles are used. Especially in waterfront structures, waterfront structures, these batter piles are used. Okay, to resist horizontal and inclined forces. Next, last one is the fender piles. Generally, fender piles fender piles are used to protect waterfront structures against impact from ships and other floating objects. Generally, these fender piles are used to protect waterfront structures, to protect waterfront structures from impact of ships. So that is the fender piles and dolphin piles. Okay. So this is the based on the function of pile. So this is the classification. Let me revise. The first one is the compaction piles. Generally, this compaction piles is used for the compaction of granular soil. Sand piles are used as a compaction piles. Second one, tension piles. Tension piles are used to anchorage down structure subjected to the uplift forces. Piles here under tension only. Okay. Third one is the anchor piles to provide anchorage between horizontal pull from sheet piling. These anchor piles are provided. Fourth one is the batter piles. Generally, batter piles are provided at an inclination to resist lateral forces and inclined forces from the waterfront structures. And fifth one is the fender and dolphin piles. Fender and dolphin piles are used to protect waterfront structures from impacting of ships. Okay, so this is the classification based on function of pile. We'll come to the next slide. Based on the method of construction, there are three types. One is the pre-cast driven piles, driven cast in situ piles, board cast in situ piles. So let us see each and every one. Generally, pre-cast driven piles. Generally, here piles are driven into soil by applying hammer blows. Is nothing but the driven piles. The first one is the precast driven piles. A precast pile is driven into the soil is nothing but the precast driven piles. Another one is a driven cast in situ piles. Piles are formed by driving a casing with a closed end to the soil. The casing is filled with reinforcement like steel and concrete. The casing may or may not be withdrawn. Okay, understanding here, drivens and cast in situ piles, drivens and cast in situ piles. Generally, these driven piles may be of concrete, steel, or timber. These piles are formed by driving a tube with a closed end into the soil strata and then filling the tube with freshly prepared concrete. Here, the tube may or may not be withdrawn afterwards. Okay, understanding here, generally driven piles are driven into the soil strata by the impact of a hammer. Generally, boring is not used in this case. When pile is driven into granular soil, it densifies the soil and increases stiffness of the soil. Okay. So here, driven cast in situ piles. These piles are formed by driving a tube with a closed end into the soil strata and then filling the tube with a freshly prepared concrete. The tube may or may not be withdrawn afterwards. Okay, that is a driven cast in situ piles. Third one is the bored and cast in situ piles. Generally, bored piles are constructed in pre-bored holes, either using a casing or by circulating stabilizing agent like bentonite slurry. The borehole is filled with concrete after placing the reinforcement. The main advantage in bored pile is no damage due to handling and driving, which is common in driven piles. The different types of bored piles are small diameter piles up to 600 mm diameter, large diameter piles greater than 600 mm, under reamed piles generally 300 to 450 mm diameter. So these are all the different types of the board piles. Okay, this board cast in situ piles are formed by making a hole into the ground and then filling reinforcement and concrete. So understanding these three types of the uh, piles based on the method of construction. Okay, initially piles are driven into the soil by applying the hammer blows. In precast driven pile, a precast pile is driven into the soil by applying the hammer blows, and then driven cast in situ piles are formed by driving a casing with a closed end to the soil. This casing is filled with reinforced concrete The casing may or may not be withdrawn. Third one is the board cast in situ piles. These piles are formed by making a hole into the ground and then filling reinforcement and concrete. Okay. So these are the different types of the piles based on the method of construction. Okay. We'll see under slide. Based on the pile driving. Based on the pile driving, there are 5 types of the piles. One is the simple drop hammer, single acting steam hammer, double acting steam hammer, diesel hammer, vibration pile driver. Let us see each and every one. First one is the simple drop hammer. Here, hammer is raised by a winch and allow to drop under gravity. Here, hammer is raised by a winch and allowed drop under gravity. Second one, single acting hammer. Here, hammer is raised by steam or air pressure and allowed to drop under gravity. Okay. Here, winch and gravity. Here, hammer is raised by steam or air pressure and dropped by under gravity. Okay. So this is about the single acting steam hammer and double acting steam hammer. Here also hammer is raised by air or steam pressure steam or air pressure and also to push down the hammer. Diesel hammer here. Coming to the diesel hammer, air and diesel oil mixer, air and diesel oil mixer is ignited when the hammer falls and that causes automatic lifting of the hammer and pushing down the pile. Understanding here, in diesel hammer, air and diesel oil mixture is ignited when the hammer falls and that causes automatic lifting of the hammer and pushing down the pile. Okay. Last one is the vibratory pile driver. This vibration technique is used for pile driving where vibrations or noise of conventional hammer driving is not permitted. Okay. So these are the 5 types of the pile driving based on the pile driving. So first one is the simple drop hammer. Another one is the single acting steam hammer. Another one is the double acting steam hammer. Another one is the diesel hammer. Another one is the vibration pile driver. Okay. Now coming to that, based on load transfer, again piles are 3 types. One is the friction pile, end bearing pile. Another one is the both friction and end bearing piles. Okay. So first one, friction piles. Generally, these friction piles are used to transfer loads to a depth in a frictional material by means of skin friction along the surface area of the pile. These friction piles are used to transfer loads to a depth in a frictional material by means of a skin friction along the surface area of the pile. Friction piles are also called as a floating piles as they do not reach the hard stratum. Okay. Second one, end bearing piles. End bearing piles, end bearing piles used to transfer load through the pile tip to a suitable bearing stratum passing soft soil or water. Generally, these end bearing piles are used to transfer load through the pile tip to suitable bearing stratum passing soft soil or water. And third one is the combined end bearing and friction pile. These combined end bearing friction and end bearing is used to transfer load through the combined action of end bearing and friction along the surface area of the pile. Okay, so these are the three different types of piles here. One is the friction pile, another one is the end bearing pile, third one is the combined end bearing and friction pile. In friction pile, load is transferred by skin friction between soil and pile, used when a hard stratum does not exist at a reasonable depth, also called as a floating piles. And generally for clay soils, this friction pile is used. Okay. Another one is the end bearing pile. Load is transferred from to hard strata through the pile tip. Okay. Used when hard strata or bedrock is available at reasonable depth. These end bearing piles also called as a point bearing piles. Point bearing piles. Okay. Next, last one is the combined end bearing and friction piles. Here, load is transferred by the combination of end bearing at the bottom and friction along surface of a pile. Okay. So this is all about the based on load transfer. Okay, types of the piles. Okay. We see next slide. Load carrying capacity of a pile. So before we discuss about the load carrying capacity of a pile, so let me revise the classification of piles on different criteria. Okay, first one is that based on the displacement of soil, there are two types of the piles. One is the displacement pile, another one is a non-displacement pile. Displacement pile means pile causes lateral displacement. Example, all driven piles. In non-displacement pile, no lateral displacement of soil takes place. Example, bored piles. Second one, based on the classification of function, there are five types. One is the tension piles, compaction piles, anchor piles, fender and dolphin piles, batter piles. Tension piles to anchor down the structure subjected to uplift forces, and compaction piles for compaction of loose granular soil. Anchor piles to provide the anchorage between the structure component and the sheet pile wall. And fender and dolphin piles are protected, used to protect waterfront structures from impact of ships. Fifth one, batter pile. Batter pile provide at an inclination to resist lateral forces or inclined forces. And then classification based on the method of installation, that is the drive piles, precast driven piles, and board cast in situ piles. Okay. And then based on the load transfer, friction piles and end bearing piles, and combined end bearing and friction piles. So these are the different types of the piles. Okay. So now apart from these classification of the piles, we'll see next how to calculate the load capacity of a pile. Okay, generally the different formulae and tests are there to calculate the load carrying capacity of a pile. We'll discuss each and every formula and the terminology to calculate the load carrying capacity of a pile. Okay, let's start. Load carrying capacity of a pile. Generally there are three four methods there. One is the static formula, another one is the dynamic formula, third one penetration test, fourth one is the pile load test. So these are the four different methods are there to calculate the load carrying capacity of a pile. So let us discuss each and every thing in detail. Okay. First one, static formula. Generally these static formulae used for ultimate load carrying capacity of a pile based on soil properties and pile geometry. Generally, these static formulae used in for granular soils, granular soils, and and cohesive soils. Cohesive means nothing but the clay soils, okay, and granular soils. Here, this static formulae is used. This static formula is used for piles in granular soils and cohesive soils. So this granular soils is nothing but the gravel, gravel, sand, and silt with no content of clay is nothing but the granular soils. Another one is the cohesive soils. Cohesive soils is nothing but the clay soil which is having the bonding between the particles. Okay, so this static formula can be used for the piles in granular soils and cohesive soils to calculate the ultimate load carrying capacity of a pile based on soil properties and pile geometry. Okay, let us see the formula here. Here two cases is there. One is the piles in granular soils is the one condition. Another one is the piles for cohesive soils. There will be two different conditions. One is for piles in granular soils. Another one is the piles for cohesive soils. Okay. Let us see each and everything. First one, ultimate load carrying capacity is given as ultimate load carrying capacity is denoted by letter here Q and suffix U. Ultimate load carrying capacity of a soil is defined as sum of the base resistance at pile tip and shaft resistance or side friction resistance. Okay, this is the formula. Simply we can say the ultimate load is a combination of end bearing resistance and skin resistance. This is nothing but the end bearing resistance. This is nothing but the skin resistance. This is nothing but the end bearing resistance. This is nothing but the skin resistance. Okay. So this is the end bearing resistance. This is the skin resistance. The ultimate load carrying capacity is nothing but the combination of end bearing resistance and skin resistance. Here end bearing resistance is denoted by letter Q suffix B. Here Q suffix S skin resistance. So QB is equal to base resistance at pile tip and QS is equal to shaft resistance or side friction resistance. Okay. So this end bearing resistance is given as product of cross section area of the at base of the pile into bearing capacity at pile tip. Very important. This end bearing resistance is given as product of cross section area at the base of the pile and bearing capacity at pile tip. Okay, and then this skin resistance is given as product of surface area of the pile and average skin friction. Okay, so here the terminology is given. AB is equal to area at the base of the pile. AS is equal to surface area of the pile. Generally, area can be written as perimeter into length here. Okay, FB is equal to bearing capacity at pile tip. Fs is equal to average skin friction. Okay, so this is about the ultimate load carrying capacity. Now we have to see that this four cases, this four terminology: cross section area at the base of the pile, and cross section area at the surface of the pile, and then bearing capacity at pile tip and average skin friction. Okay, so let us see each and every terminology in detail. Okay, so simply the formula is Q suffix U is equal to AB into FB plus AS into Fs. Okay, note down this formula, very important, this static formula. Okay, okay, this is the static formula used for ultimate load carrying capacity of a pipe. Okay, for granular soils and cohesive soils is given is. Coming to the next slide, for granular soils, this is for granular soils, nothing but the, particularly I told you the granular soils, nothing but the gravel, sand, silt come here. Okay, so for granular soils, okay, first one here, bearing capacity at pile tip is the terminology FB is equal to vertical stress at tip level into bearing capacity factor. Okay, generally there are three types of the bearing capacity factors are there, which is given by the chems also, Spence curve, that are NC, NQ, under one is the N gamma. These bearing capacity factors are already discussed in shallow foundations. Okay, generally these bearing capacity factor, in particularly in sand, uh, will be taken. Okay, let us see here three different bearing capacity factors. So first one is that bearing capacity. Here FB is equal to vertical stress at pile tip level into bearing capacity factor, that is the NQ. Okay, here NQ is equal to bearing capacity factor, that will be given. Okay, sigma V dash, here effective vertical stress at pile tip level is equal to gamma dash into L. If here L stands for length of the pile, if length of the pile is less than critical depth, then it is unit dash. Okay, So gamma dash is nothing but a submerged unit weight here. Okay. And then is the length of the pile. If length is less than critical depth, we'll take length here, length of the pile. If critical depth is less than length of the pile, we'll take here critical depth. So as a vertical stress at pile tip level, sigma V dash is equal to gamma dash into L, gamma dash into DC, depending upon this condition. See? Here L is equal to length of the pile, DC is equal to critical depth, depends upon the soil type. Critical depth is the depth up to which the effective vertical stressor increases linearly. Okay. Here the critical depth is 10 times the pile diameter for loose sands, 20 times the pile diameter for dense sands. Okay. And similarly the skin resistance Fs is equal to K into sigma A dash into tan delta. Here sigma A dash is nothing but the average effective vertical pressure for the depth considered. Okay. K is the lateral earth pressure coefficient. Delta is the angle of friction between pile and the soil. Okay. So here two things given. One is the FB and FS. Okay. Similarly, in coming to the piles in clay, the cohesive soils, FB is given as C and C. I told you that C is the cohesion of the soil at the pile tip, or shear strength of a soil at the pile tip, and NC is a bearing capacity factor, whereas for Fs is nothing but the alpha into C. Alpha is the adhesion factor or shear mobilization factor. Okay. C is the average cohesion or shear strength along the pile shaft length. Okay. So finally, the formula is given as, I told you that generally QU is equal to AB into FB plus AS into Fs. Here FB is nothing but the terminology called as sigma V dash into NQ. That's the vertical stress at the pile tip and then the bearing capacity product. And similarly here Fs skin resistance will be the average vertical pressure into the here tan delta. Delta is nothing but the factor. Okay. Majorly this adhesion factor is very important. Okay. And similarly again this for clays, this FB is given as CNC cohesion and bearing factor. Here alpha C, this adhesion and cohesion factor. Safe load, that is QS, is equal to ultimate load bearing capacity by the factor of safety. Safe load is equal to ultimate load bearing capacity by the factor of safety. This factor of safety as per Indian standard will be taken as minimum as 2.5 in static formula. Okay. 2.5 in static formula. These for the sands, these for the clays. Okay. So these are the two different formulae, very important you need to remember in all the examinations, in particularly in GATE examination. Okay. So let us see one problem so that you can clearly understand here. A pile is driven in a uniform clay of large depth. The clay has an unconfined compressive strength of 90 kilonewton per square meter. The pile is 30 centimeter diameter and 6 meter long. Determine the safe load carrying capacity assuming factor of safety as 3. Assume adhesion factor is 0.7. See here we need to calculate the safe load. We know that safe load is nothing but the ultimate load carrying capacity of a pile to the factor of safety. here in the problem already it is mentioned that the factor of safety is nothing but the 3. Now we need to calculate the ultimate load, that is nothing but the QU. We know the formula, that is AB into FB plus AS into Fs. Okay. So first we need to calculate the term called AB. So here the pile is 30 centimeter diameter, that is circular. Okay. We know that was the formula for the circular, that is a pi d square by 4. Okay. Pi d square by 4 here. Here D nothing but the diameter of the pile. Okay. That is 30 centimeter. We take generally 30 centimeters in terms of the meters, that is the SI units, that is the point 3 whole square. Okay. And then the term called as AS. Okay. So the surface area of the pile is AS is equal to, I told you that perimeter into length. Perimeter is nothing but the pi into D into length. So we know that diameter of the pile is nothing but the 30 centimeter. So D is equal to 30 centimeter is equal to 0.3 meter. Okay. So similarly, the length of the pile is given as 6 meters. Here length also given, that is length is equal to 6 meter and diameter is given as 0.3 meter. By substituting these values here, we'll get pi into zero point 0.3 into here. Now we need to two terms. One is the, we got cross section area at the base level and surface cross section area. Now we need to know that here the terminology called as FB and Fs, that is the surface average skin friction and bearing capacity at pile tip. First we'll know the value of FB, that is the bearing capacity at pile tip. FB is equal to bearing capacity at pile tip is equal to given as. So first of all, in this problem you need to understand that this is the formula for the clay. Okay. For clay, we know that FB is equal to C into NC. NC is the bearing capacity factor. Okay. So this NC will be the bearing capacity factor is nothing but the NC is nothing but 9 we take generally, which is given by the Skempton. Okay, NC is equal to 9. Coming to the C here, C is nothing but the cohesion generally of the soil at the pile tip, which is taken as the shear strength of the soil at the pile tip, which is half of the compressive strength. Okay, so this cohesion of the soil at the pile tip is nothing but the 45 kilonewtons per square meter, which is taken as half of the compressive strength. Okay, so we'll get here CNC, and then if you calculate the Fs value, that is the skin resistance, is equal to alpha into C. Alpha is nothing but adhesion factor, already it is given as 0.70. Okay, and then substituting this cohesion value as 45 kilonewton per square meters, will get try to substitute in this formula. So ultimate load bearing capacity by factor of safety. Factor of safety is given as 3. and base area is nothing but here pi d square by 4, that is the diameter is zero point 0.3, okay, and then cohesion is nothing but the 45 kilonewton per meter square, and bearing capacity factor is taken as NC is equal to 9, and then surface area of the pile is nothing but the perimeter pi d, here is the diameter is 0.3 meters and length of the pile is 6 meters, pi d into L into adhesion factor is 0.70, and then cohesion is 45 kilonewton per square meter. By substituting these values, finally we will get the safe load carrying capacity of a pile is 68 kilonewtons. So understanding this problem here, basic thing is that you need to understand it is given for granular soil like for sand or gravel or silt, or it is given for the cohesive soil, that is nothing but the clay. Depending upon the formulae, you have to substitute these values. Okay, this is about the static formulae, how to apply for that.